Okay, so first of all, who would like to tell me which ones of these can be found without using a calculator?
This is Emily.
Emily,
Um,
tell me just one of them.
Tangent of pi over 3.
Okay, tangent of pi over 3. And what is the tangent of pi over 3 without using a calculator?
Root 3.
And how'd you get that?
So I looked on the unit circle and
Okay,
I used the points of pi over 3, which is 1/2 root 3 over 2. And since tangent is y over x or sine over cosine, I plugged those in and I simplified from there.
bam. Okay. Okay, who else? Somebody else? Without using a calculator, which ones? Come on. Is anybody else there? So are you quiet because we don't really know? So everybody,
This is Tanner.
okay, Tanner.
So the cotangent of pi over 2, right?
Cotangent.
Yeah, so
Wait, let me get back there. Okay, go ahead.
that's just
All right.
pi over 2 divided by pi over 2, right?
Okay,
No.
so first of all, let's define the cotangent.
Oh,
Since
okay,
the tangent
cotangent.
is
Oh,
y
yeah,
over-
never mind.
yeah. So the tangent is y over x. So what's the cotangent going to be? Since it's the reciprocal, the tangent and the cotangent. So cotangent
Yeah.
is going to be x over y,
Y.
correct? Okay, so what are the coordinates of pi over 2? The point at pi over 2. What are the coordinates of the point on the unit circle at pi over 2?
90
This is
degrees.
George.
90 degrees, but okay, I'm
0
sticking
and
with
1.
Yeah, okay. So 0 and 1 are the points. So what's x over y? 0
Divided by 1
divided by 1, which is
undefined, I believe.
nope, no, it's good. You can divide by
Just
1.
0?
Yeah, you can't divide by 0. So the
Okay.
cotangent of pi over 2 is 0. You can check these on your calculator, you guys, but you don't need to use a calculator for some of them. Okay, did that make sense, Tanner? You kind of started it and then went, okay. All right, so let me work a couple of these then. Cosecant of 30 degrees. Okay, first you ask, what is cosecant? Oh, that's 1 over sine, or the reciprocal of sine. And I know sine is the y coordinate, or if there's a radius, y over r, but these are all unit circles, right? Because we don't have any circles actually. So we know that it's going to be 1 over y. And what is the sine of 30 degrees? The sine of 30 degrees is the y coordinate, which is 1/2, because it's radical 3 over 2, 1/2, correct? So 1 over the sine would be 1 over 1/2, or if you flip 1/2, you get 2. And you can check that on your calculator. Okay. The reason I'm giving you this is because if it's on the unit circle and you give me, if the answer, well, let's do this one. The secant of negative 45 degrees. Oops, let's go right here. That's also on the unit circle, okay? So what does secant mean? Does somebody want to take this besides Emily? Tanner, do you want to go for it? You were starting the other one. Or Joel, or somebody else comfortable yet? Shall I do it myself? Okay, I'm
I'm
gonna
really
do this.
comfortable with it.
Okay, so secant is, first of all, you have to know all these things, and if you don't have them right in front of you, I gave you the sheet. Secant is 1 over cosine. So that means it's 1 over x in this case, because cosine is going to be the x coordinate of this puppy. Now, at negative 45 degrees, we need a positive x and a negative y because we're in quadrant 4. So the cosine is going to be radical 2 over 2. So I need 1 over that. So 1 over the square root of 2 over 2 means you just flip it. So it's 2 over the square root of 2. That's not one of your questions you guys sent me. Somebody sent me, maybe Carson, I'm not sure. Said, do we always have to simplify the fraction, get rid of the radical? Yes. So 2 over radical 2, of course, I'm totally out of room here. Oh, no. Okay. I can rationalize that denominator. And I'll get 2 times radical 2 over 2, which also reduces to the square root of 2. Now, you might be thinking I'm crazy going through all this, right? But if you do that on your calculator, you're going to get a 1.14, whatever the square root of 2 is. And if I want the exact answer, because it's on the unit circle, you need to be able to give me the radical. Okay, so just remember, if it's on the unit circle, take the x and the y coordinates and figure it out from that. But if it's not on the unit circle, then go to your calculator. Questions on that?
Marge, this is Jennifer. I have a question.
Okay, Jennifer.
So if it's just a negative degree that is on the unit circle, then you just flip the signs depending on what quadrant it's in?
No, so good question. If it's a negative degree, that means you're going this way around the unit circle. Okay, so like if it was a positive 45 degrees, you always go counterclockwise. But since it's a negative 45 degrees, we're going clockwise, and that's down here. So that puts you, in this case, in quadrant 4. I mean, if I went negative 300 degrees, I would go all the way up here. That's negative 300 degrees. And that leaves me with 60 degrees left. That's my reference angle, is 60 degrees. And it doesn't have, the sine and the cosine are both positive there. It just depends on where the angle is. And wherever that angle takes you determines if it's a positive sine or positive cosine. Okay?
Thank you.
Okay, did that make sense?
Yes.
Okay. Okay, so the last two are over here. The sine of pi over 5 and the cosine of 221. Yep, those are calculator problems. So last but not least, do the sine of pi over 5 and you should be in radians. Otherwise, you're not going to get the right answer. And you should get 0.3, right? Wrong. What is it? Point. Who's got it? 5, 8, 7. I'm going to round it off to 8. Anybody agree with me?
Agreed.
Yes?
I agree.
Okay. Thank you. Okay. I just need 3 people and then I know we're good. How about cosine of 221? I go to my mode, I go to degrees, and I do cosine of 221. And who wants to shout it out?
Negative 0.7547.
Is that Emily?
Yeah, sorry.
Negative 0.75. I'm going to round it off to 5.5. Why is it negative, not Emily? Why is it negative? Here's my picture. Here's my angle. Why is the cosine negative?
Because it's in a quadrant with a negative x.
Yes, thank you, Xander. And which quadrants have a negative x, Xander? What's the other quadrant?
3 and 2.
3 and 2. Yep.
Yeah.
All right. Okay. All right, moving on. Margie said that if you try to find sine or cosine of an angle on a calculator and it's greater than 1, you have an error. I should have remembered that. If you won't get it, it will say error. If you try to find the sine or cosine of an angle that is great and it is greater than 1. So for example, if you said the sine of some degrees, 382 degrees, and they gave you on the calculator, they gave you 1.5. She says that's ridiculous. Anybody want to comment? Or cosine of negative 512. She said anything greater than 1, so or 2.8. Anybody know why?
I think this is Joel. I think it's because in the unit circle, what is it? Radian or
Radians.
yeah, it just goes beyond, or actually doesn't go beyond 1. So it might be the reason that's why you cannot do that
Oh,
in
the
the
radius, you mean? The
Yes,
radius.
yes,
The
sorry.
radius. You're exactly right. Okay, on the unit circle, the radius is 1. And so the cosine is any point on the x-axis. It's the coordinate of these points. So if I'm talking 382 degrees, 360, that's coterminal with 22 degrees, because I go all the way around the circle, 360 plus 22. And the cosine is going to be, it can't be more than 1.5 because that's off the unit circle. Do you see? Cosines will never be more than 5, and they won't be less than, I'm sorry, no more than 1. And they won't be less than -1. So sines and cosines both only go to the unit circle. It's only up to 1. All right. Otherwise, you have to divide it by the radius, and you still get something less than 1. Try it on your calculator, sine and cosine of everything. Okay, here we go. The tangent of the 12 non-quadrant angles on the unit circle is either plus or minus square root of 3, plus or minus 1, or plus or minus radical 3 over 3. I'm going to do this one with you. Okay, so we have the pi over 6 family, pi over 3 family, and pi over 4 family. So which go with the pi over 3? Here's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay. Okay, so what is the tangent of pi over 3? That's y over x. So this is my, this is square root of 3 over 2. Nope, this is 1/2. Cosine is 1/2, and sine is radical 3 over 2. Right? So the tangent is y over x. So which one is it? Is it plus or minus radical 3? Yes, it is. Right? Because y over x is going to be square root of 3 over 2 over 1/2. And we know that the 2's cancel. So it's radical 3. Yes? How about 2 pi over 3? Same points, only one of those negative, yes? Which one's negative? Cosine, right? Quadrant 2. So we have negative radical 3. We still have y over x. Everybody agree? It's the same point, the same y over the same x, only this time it's got a negative because it's actually -1/2. If we go down to 4 pi over 3, who can tell me what is it? What's the tangent of 4 pi over 3? That's over here. It's the same point, only they're both negative. -1/2, negative radical 3 over 2. So the y over the x is going to be negative over negative, so it becomes positive. So the pi over 3 was positive, 2 pi over 3 was negative, 4 pi over 3 is positive, and who can tell me the last one? 5 pi over 3 is, Jennifer, go ahead.
-√3.
Because
Because the sign is negative, and so one
Nice.
of the values will be negative.
very nice. Okay, so that's called a family of pi over 3, and they all have either plus or minus radical 3. Okay, so let's look at the family of pi over 6. I hope you got all that because I just erased it, but we are recording. Okay, so let's go with pi over 6, and that gives us this guy, this guy, this guy, and this guy. This is the family of pi over 6 that's on the unit circle. Now, who wants to go through and help me with this one? Oops, I got two things there. Okay. And 11 pi over 6. First of all, they're either going to be plus or minus 1 or radical 3 over 3. We know it's not the other one because we already used them. So the point is radical 3 over 2, comma 1/2. That's our point in quadrant 1. So I take y over x, I get 1/2 over square root of 3 over 2. The 2's cancel out, and I get 1 over the square root of 3, which is not in simplest form. So we have to rationalize it. And if you did your flippers that I gave you last week, you would have the square root of 3 over 3. That's this one. Yeah. Okay, so pi over 6 is the square root of 3 over 3. Finish up. That's 5 pi over 6. Not Jennifer, not Joel, and not Emily. Who wants it? Okay, anybody? Makes me nervous. I wish I was in the classroom with you. Okay, so pi over 6. 5 pi over 6 is the same point. It's the same two numbers, y over x. But the question is it positive or is it negative?
Negative.
Who said that?
That's Emily.
Emily. Okay. Anybody agree with her?
I agree. This is Jennifer.
Jennifer. Anybody else? Why is it negative, I guess? Why is it negative?
Is it because it's in a quadrant with a negative cosine?
It is. Good. Thank you, Xander. Okay, so which is the cosine here? It's the radical 3 over 2, right? So it's going to be a positive 1/2 divided by a negative, and that gives us a negative. And 7 pi over 6, tangent's going to be, everybody,
Positive.
Positive, because it's a negative sign divided by a negative cosine. And how about 11 pi over 6? It's going to be negative. Okay, I'm trying to show you patterns of tangents. All right, that's what this little exercise is about. Okay, the last ones are the easiest ones. I saved for last, because that is square root of 2 over 2. X and Y are both square root of 2 over 2. Okay, so the question is pi over 4. We know that's positive because they're always positive. So that's going to be positive 1, because this divided by this is 1. And the next one, what's our next angle that goes into the family of pi over 4? Somebody. What's the angle over in quadrant 2 that goes with pi over 4? Has the reference angle of pi over 4.
This is Joel 45.
How much?
45.
45 is in quadrant 1. What's the one in quadrant 2? With a reference angle of 45 degrees.
I'm guessing that's 135.
Yeah, you don't have to guess. Nice job. 45. It's 45, and this guy is 135 because the reference angle is 45. Okay, so I'm going to put 3 pi over 4 because we're doing radians. Is that positive or negative?
That's going to be negative.
Okay. Thank you, Xander. You always get that question. And Darius, I saw yours in there. So, okay, so that's going to be a negative 1. And how about down here? What's the angle? These are all the angles that have a reference angle of 45 degrees. That's going to be 180 plus 45. 225. And what's the radians? This is pi over 4. 3 pi over 4. 4 pi over 4.
5 pi over 4.
5 pi over 4. And that's going to be positive. And then this one is 6 pi over 4. We don't care about that. 7 pi over 4 is negative. Okay. All right. Break as needed. I see some of you guys are doing that. I'm going to keep on going. Margie said that since sine squared plus cosine squared equals 1, she could conclude that, well, sine equals 1 minus cosine. And Bradley said, you can't do that unless they're squared. It's got to be squared. So he's saying you can do that, but sine squared equals 1 minus cosine squared. What do you think? The question is, does this work or does it have to be squared? The only reason this, oh, I got it. I got a chat here. It does, Darius, you're right. It really does have to be squared. And the reason is it's the Pythagorean theorem. And the Pythagorean theorem only works with squares. A squared plus b squared equals c squared. Okay? So the reason this works, sine squared plus b, because that is on a triangle. This is my cosine, this is my sine. So it's going to be sine squared plus cosine squared equals 1. So this is bogus. Margie's wrong. Bradley's right. Moving on. All right, let's all do this together on paper. Show how to change this into another Pythagorean identity by dividing each term by cosine squared. So write this down. Sine squared theta example of a question that you might get on a midterm. Okay. Ah. Okay. Hopefully, I'm just going to go and do this one and then let you guys work the next one on your own. So this one, I'm going to divide everybody by cosine. I did this in the video. I think I divided them by sine in the video. And by the way, as long as the cosine is not 0, I can do this because you can't divide it by 0. So what is sine over cosine? That's tangent. So sine squared over cosine squared is tangent squared. And cosine squared divided by cosine squared is 1. And 1 over cosine is secant. So 1 over cosine squared is secant squared. And that's how they got this. This is another Pythagorean identity. And there were two of these in the video I gave you. One with secant squared, or one with cosecant squared. Okay. Before we go there, I want to ask one more question. Right, I guess I'll just do it right here. What is the tangent of pi? Use your unit circle and tell me what the tangent of pi is. I'm going to count to 3, and I want everybody to say something. Don't be shy. Okay, are you ready? 1, 2, 3.
0.
0.
I got lots of zeros. Anybody have a different answer?
No.
No? Anybody yes? So the coordinates of pi are -1, 0. Everybody good? So how did somebody get 0? Is it just the y coordinate here? How do you know the tangent of pi is 0?
0 divided by -1.
Okay, y divided by x. Okay, then what is the tangent of 2 pi? I'm gonna count to 3. Tangent of 2 pi. One, two, three.
0.
0, 0,
Zero.
0. Okay, right on. Let's get on this. Okay, let's do the tangent of pi over 2. And you know what I'm gonna do last. Tangent of pi over 2. Ready? 1, 2, 3.
0.
Undefined.
Undefined.
Uh-oh.
Undefined.
Why is it undefined?
You can't divide by 0.
Okay, it's 1 over 0, which is undefined. And in my next set of videos, you're going to find out there when you graph the tangent at the point 0, when x equals 0, the tangent is undefined. That means there's an asymptote in the graph. And anytime the value of sine, cosine, tangent, or any of those, secant, cosecant, or cotangent, anytime the value is undefined, that means the graph will be an asymptote. That'll make better sense. How about 3 pi over 2? What's the tangent of 3 pi over 2? 1, 2, 3.
Undefined.
Undefined. That's another undefined. Okay. All right. Here we go. Which of the following can be simplified to either cosine or sine? Go ahead and do these on your paper. I guess I'll do one. I'll do the first one to show you what I'm talking about, because Okay, so let me see, which one shall I pick? I think I'll pick this one right here. Secant tan. Okay, so to simplify it to cosine or sine, I have to change these to equivalent expressions. So secant is the same as 1 over cosine of theta. And tangent is the same as sine over cosine. And all I get is sine over cosine squared, and that is not simplified to sine or so that one's out. Okay, you guys do the other 5. There's at least one simplifies to either sine or cosine, and then do the proof like I did. Okay, Darius, would you explain out loud what, oh, you can't. Okay. Okay, I just read the chat from Darius, and I'm going to do what he said, which was tan cotangent simplify to cosine because the tangent equals sine over cosine. So I'm going to, oops, I'll write that. So sine over cosine. And cotangent equals cosine over sine. And then we have that cosine repeated here on the bottom, okay? And he said, or they said, cancel each other out. And if you write them as fractions, like
Hey,
this, so I'm gonna go ahead and cancel these out. What did I do wrong?
Am I audible?
Hey, you are! How did that happen?
I don't know.
Oh my
literally
God.
plugged it and plugged it in again, which is what I did
There you
last
go.
time.
Yay! So you finish
Okay.
explaining this. Oh my God.
All right, where were we?
I think we should start over because I can hear you now. Okay,
Oh my
go for it.
goodness, that's a miracle. All right. I started backwards. I started with the
That's
tangent times cotangent divide times cosine. So tangent is, all right. Let me look. Is it sine over cosine or is it cosine over sine? Tangent is sine over cosine. And then cotangent is the inverse of the tangent. So it's cosine over sine.
Absolutely.
and then that's times cosine. But we can make our nice little X there to cross out because the sines cancel each other out and the first two cosines cancel each other out. So we can make our
Okay,
nice
so
little,
these cancel. I'm going to put ones
Yes.
there just because, and then these cancel to one whole. Okay.
yes, we can make, yes, and that just leaves us with cosine.
Yes, it does.
One
Nice.
times one times
Right
cosine.
on.
Oh, it's so
Okay.
nice being able to speak.
Yay, welcome back. I know.
Uh,
Oh, okay, who's taking another one? Darius, I know you want to probably keep going, but I'm going to give you a little break.
yes, yes.
You got to make up for lost time. Would somebody did somebody find another one that's either cosine or sine?
I tried to do cosecant and tangent data.
Okay, and what'd you get
So
there?
I for cosecant I got 1/sine data,
Mhm.
and for tangent I got sine data over cosine data.
Okay.
So basically I just cancel the sine data,
Right.
and I got 1/cosine data, which is according to my formulas here, I think it's secant data.
It is.
All
And
right.
that is not sine or cosine. Nice job, Joel. Okay, somebody else want to take a different one, either prove it right or wrong. Either, just work it out so it says either it is cosine and sine or it's not.
I did, this is Jennifer.
Jennifer?
I did the cosine and the tangent.
Okay.
And then the cosine, it just stays a cosine. And for tangent, it's sine over cosine. And so you can cross out the two cosines and you're just left with sine.
Yay! All right. Thank you. And there's two more. Who would like one? Natalie, are you still here with us? I want to make sure you get a chance. If you want. You want a chance to say something? That was a good time. Okay. And Carson, been a while since I heard from you.
Yeah, I'll do one.
Okay.
I did sine and cotangent. And so cotangent is cosine over sine. And so sine wouldn't change. So you would just cross cancel the sines out, leaving it with just cosine.
All right. So that one works. Okay. I'm just trying to give everybody a chance here. So Tanner, let's see. Natalie. One more. Is there any way that sine and cosine are going to cancel out, you guys? Is there any way that's going to change to a sine or cosine? No. That is all you get with that. You just get sine, cosine, and there's nothing you can do about it. So we're done. So the only two that actually three of them simplified to sine or cosine were those three. Okay. All right, number 9, find the cosecant when the terminal side of theta passes through -4, -3. This is an example of the extra credit problems I sent you guys an email giving extra credit this week. It doesn't do you any good unless you're doing your assignments, but it does do you good and it gives you a lot of extra practice. I mean, it doesn't give you points. The practice is awesome. So if these I gave, there's about 1, 2, 3, 6, 12 or more problems that you can do on section 5.40 practice, and I put it in the book as extra credit, and on your final I can throw in there for you. Okay, assuming you're not, assuming you are. Extra credit doesn't make up for no work; it's just more work.
I cannot hear you very well.
Oh, okay. Thank you. Okay, go ahead and do this problem. I'm going to switch to the other computer. Would somebody volunteer to be the new host while I'm gone? Just in case. Darius, would you do that? Are you there?
Sure. Yes.
Okay, you probably won't need to do anything, but it says, so I'm gonna do it. Okay, I'll be right back.
All right. I am the host. Okay. Let's see.
Can you hear me?
I can.
Okay, I'm back. Okay, I'm going to start doing this problem. First thing I would do is I need to find the cosecant. I just say, oh, that's 1 over the sine. So I'm going to need, or actually, sine is y over r. So cosecant is r over y, if you want to think of it that way. Okay. So I'm going to plot that point. -4, -3 is in quadrant 3. So I have -4, -3, and that's my x and that's my y, and I need my r. So I need to use the Pythagorean theorem. And oops, I did that backwards. This is one of those famous Pythagorean triples, 3, 4, 5. So anytime you get a 3, 4, 5, make sure they're in the right spots, but r squared is 25, so r equals the square root of 25. Okay. And just make sure you're in the right quadrant. I please ask my students to do a sketch, and I require that on tests to prove it. So I need the cosecant, which is 5 over -3, right? Or -5/3. If you agree with me, yes? Anybody have a question? Agree? Okay. All right, here's another one. You got to be able to do these really well. These are the important ones. Okay, by the way, I don't want to go too fast. Is everybody clear on what we do?
I have a little trouble visualizing everything as a triangle, which I know I should because it's called trigonometry.
Right.
I keep
Okay,
trying to
so-
visualize everything as a circle because we're dealing with unit circles.
Yeah. Okay, just remember now the unit circle is this big. And then when we have real points, anything on a unit circle is nothing bigger than
Very
1.
small.
Yeah, so we've got to go way out here. So we're
I've
going
just
to go.
gotta
Yeah, so go out
break
here
that
to
mental
-4.
block.
Just realize it's out on a bigger circle. Oh,
Mhm.
I've already lost it. Okay, so here's the next problem. You can see it at the bottom of your screen. And this is an example of one from the extra credit sheet. So you know what they're like. Sorry. Okay. Okay, thank you. Okay, so I'll draw the picture again, quadrant 3. We know the secant is -9/4. We know that the secant is 1/cosine. This is what I think in my head, okay? The secant is 1/cosine, which is, and cosine is x/radius. So cosine equals x/radius. Secant is going to be the radius over x. All right. Now, we know that we got a 9 and a 4, okay, and one of them is negative. Okay, so we know it's -9/4, but it could be 9/-4. We just don't know. All right, so we've got to put it in quadrant 3. Now, here's where you draw the triangle, Darius. You want to make sure that the right angle is on the x-coordinate, or sorry, the x-axis. And that way you get your x, your y, which is going to be helping us to get the x, the y, and the r is what we want. All right, so we know that the radius is never negative, and we know that both the x and the y are negative in quadrant 4. Agreed? So we know that r is 9 and x is -4. We know that because the radius is positive and we need a negative x coordinate. Okay, and we just need to find, once you get that thinking, maybe just use the Pythagorean theorem and find y, and then the tangent is y/x. But you gotta use your thinking to take secant here and get to which one is x, which one is r, and which one is negative. All right, so we have -4 squared plus, I'm going to get rid of these guys, something squared equals 9 squared. So 16 plus y squared equals 81. So we'll subtract 16 from both sides, and we'll get y squared equals, take away 10 is 71, take away 6 is 65. So y is going to be plus or minus the square root of 65. And I believe that's in simplest form. If plus or minus you ask, well, it's y. Who said?
Marjorie, you were kind of cutting out for that last bit there when you were talking
Okay.
about once we got to 65.
Okay, the question is it plus or minus? And so since it's in quadrant 3,
It's gonna
negative. It's
have to be
negative.
minus.
Yep. because x is negative, y is negative. So what's the tangent? Y over x. So negative radical 65 over negative 4. Please don't leave two negatives in your answer. Simplify that to radical 65 over 4. Thumbs up, yes, questions? Okay, thank you. Label the sides of the triangle so that you can find x using the cosine function and this equation. I'll give you a hint. This one's 90. One of these is going to be 58. And I'm going to have to put either 5 or x here, 5 or x here, 5 or x here. And then when I set up an equation to solve for x, it's going to be cosine of 58 degrees is 5 over x. So you want to put the 5 and the x and the 58 somewhere on that triangle. So this is true. I'm going to label these so you can talk to me. I'm going to call this, I think I'll do it in, this one's going to be A, this one's going to be B, this one's going to be C. And that makes this little a, little b, and little c. You want to take this one?
I can. This is Emily.
Okay, Emily.
So I put 58 degrees at angle B. And then I put 5 at little a and x at C.
All right, let's see if this works. So the cosine of 58 degrees is the adjacent over the hypotenuse. And we know the hypotenuse is x because it's crossed from the 90 degrees, it's alongside. So adjacent is the other one that's right next to 58 degrees. Adjacent means next to. So that means it's 5. So the adjacent is 5, the hypotenuse is x, and you did it right, yay! Now, if I were to keep going, how in the world would I solve this problem? You want to keep going, Emily?
No.
Okay, somebody else?
Well, since I don't know if I can solve the whole thing, but I do know the next step.
Okay.
Since we know that angle is 58 and the other is 90, all the angles in a triangle have to be 180 degrees. That means the next angle has to be 32 degrees.
Okay, so up here at A, 32 degrees.
That's a hint.
I will agree with that. Okay. Somebody want to, thank you, Darius. Somebody want to jump in here? I want to find X.
Do you just solve for x using the equation?
Yeah. Yeah. Just use this equation. So what do I do?
You would want to get the x by itself. So I would multiply x on both sides.
I'm going to rewrite it this way so it looks better. Okay, multiply X by both sides. Good. And
Then,
that cancels.
yeah. And then you would divide each side by cosine of 58 degrees.
Okay. So this is a real important lesson right here, you guys. You don't want to find the cosine of 58 degrees and round it off. You want to just put this whole problem together so you get the most exact answer you can. Okay, so go ahead and put that in your calculator because these will cancel and you get X equals whatever 5 divided by cosine of 50 degrees is. Make sure your mode is decreased. And 1, 2, 3 is it. If you haven't answered in a while, you want to step in here.
0.5299 and so on. Not sure about that.
Yeah, I got something bigger than that. 5 divided by the cosine of 58 degrees. This
Oh,
is the
sorry,
length of the triangle.
Sorry.
Yeah.
Yeah, I did it wrong.
Somebody else?
I got 9.4354.
Okay. Now, when we're getting lengths of a triangle, they'll usually say, hey, to the nearest thousandth is fine. But if in doubt, 4 places, but I'm going to say the length of that is going to be about 9.4. Okay, there's no units here because there's no reason or there's no application. Okay, questions? This is section 5. All right, what is the difference between an angle of elevation and an angle of depression? That's the difference here. Quickly. Okay, I just want to make sure angle of elevation starts on the ground and moves up. And an angle of depression starts also on, I'm going to call the horizontal, but it moves down. So it swings down. So this is my elevation. They might call it inclination. There's different ways to say it goes up. And this is my depression, or what else did they call inclination? Maybe. And I think I showed you, and I know I showed you in the video. If you have a triangle, this angle out here is also the same as this angle in here. And you're going to be using a right triangle to create a problem forum this week. Read your problems. They need to be in by Sunday, so people have to answer them. And then somebody else, you say, wow, I got a whole different answer. Show them your work. Or that's the same answer I got. Hello?
Yeah, we can really
Did somebody-
for a little bit there.
Okay. Am I better?
You're better now, yeah.
Okay. So I was talking about the forum. And when you create a really awesome application problem, or I think I did, then when somebody answers your problem, you need to give them feedback. And then you need to answer somebody's problem. So there's 15, 5 points to create, 5 points to answer somebody, and 5 points to give them feedback and show them your work. Some of you guys didn't make it this week on the forum. We missed you. So please, yes, these are becoming more important every week because you're just so these are important ones where you create your problems. Okay, so and by the way, the angle of elevation is the same as this angle of depression because they're called alternate interior. They swing around. All right. I'm going to stop right here. This last problem was an example from the extra credit I gave. So if you you draw a picture and it's like two buildings are 50 meters apart, so you would draw 50 meters, and then you would have this building and this building, and from the top, the taller building, which is 200 meters high, the angle of depression to the top, oops, typo, of the shorter building is 15 degrees. So this angle of depression to the top of that building right here is 15 degrees. Find the height of the building. So that would be my X. So you'd have to like figure out how to use this 15 degrees. This is also an example of a problem you could share using right triangles. So no, here's a triangle, but it doesn't, you've got to work to this angle right here. This 15 degrees is the same as this 15 degrees. This 50 is the same as this 50. This whole thing is 200. This is 200 minus X. Anyway, so I'm telling you, if you have to credit, the answer is with it. So you're honored of not to use the answer to the problem unless you're absolutely stuck. In which case, take a peek. Take a peek and then go back and do it. All right. I want you to do the problems. That's why I put the answers there. I don't want you to be stuck and say, "I'll forget this." Okay. Okay. Now, next week we don't meet at Thursday at 1 o'clock because of my tooth surgery. So you guys can schedule a Zoom with me. And the rest of these problems that I sent out to you, I sent them out because you need to do them before our Zoom, even if you do it wrong. All right, this seems to be next videos before we. It's like difficult for some of you, so I'm going to try to meet with you Monday, Tuesday, or Wednesday, or Thursday morning. So what I'd like to do, I'm not going to go over these. These are the new questions that we have the rest of this lecture. Okay. So what I'd like to do, if you can still hear me, yes, can you guys still hear me?
It's a little crackly.
All right. You can text me when you can come. Joel, I talked with you earlier, Tuesday, 10 a.m. Now we can do one person or up to 3 people, be okay, but no, I really like to have small groups. So do you see a time that works in your schedule right now? And please let me know. If I'm meeting with you on Monday and you don't watch new videos, you can another time take me after the videos.
You're cutting out pretty bad, Marge.
Oh, shoot. All right.
At least for me anyway. I don't know.
Is this any better?
That sounds better.
Okay. If I cut out, you guys, I figured out my software. I mean, my computer, my hardware is about a 2-hour limit and we're on 2. So would you, if you can't tell me right now, I need you to text me or text me, but do chat and tell me what I'm doing. Say it out loud and I'll write your name in here for me. So Tuesday's a good time. I've got Tuesday at noon, Wednesday at 10, Wednesday at noon, Wednesday at 3, Thursday at 10, Thursday at noon. And if none of those work for you, then we work it out. I can do afternoon, evening, but I need to be careful with that. So usually, Marge, really, the only time I can meet with you before Thursday is, and we set it up. Okay, so give me a time right now. This is next week Zoom. Everybody clear on that?
Marge, you're cutting out super badly.
Ah. All right. 2, 3, 4, 5, 6. Can you guys hear me?
Yes.
Good.
Yes.
All right. It's kind of weird there for a while. Does this look okay? Katrina, I don't have you down. So I know we're meeting Monday, but if we don't get the videos, let's set up another time too. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. Okay, I'm going to save this and stop that. And I have one last thing, and that would be your questions. Just so you see the different kind of things you guys are sending. The first one says, can you re-explain converting sine to cosecant? And you can't convert sine to cosecant because sine of theta is equal to 1 over cosecant of theta. So they're reciprocals. Okay. And so if the sine of an angle was 1/2, the cosecant would be 2. So cosecants and secants can be more than 1. Clearly, they will always be unless they're equal to 1. And also, they wanted this one explained, which is cosecant, I'm going to put theta instead of x, divided by cotangent theta. So always, if in doubt, change it to sines and cosines. So cosecant is 1 over sine. Cotangent is cosine over sine. And we've talked, if the fractions have the same denominator, they cancel out, which leaves me with 1 over cosine. And otherwise, you would times by the reciprocal of the denominator, and you'll still get 1 over cosine, which turns into secant. Yay! The next question, must I always simplify the bottom if there's a square root? Yeah, we talked about that. And the reason is the denominator of a fraction tells you how big it is, the size, 1/3, 1/4. And if you say, oh, I have 1 radical 2 of the pizza, you know, that's my fraction of the pizza is 1 over radical 2. That's just not cool. So it's more simplified. Is the hypotenuse, opposite, and adjacent going to be the same no matter what type of angle it is? And these are only factors that work with a right triangle, and it depends on where you're standing. If you're standing here, then the opposite is over there. If you're standing here, the opposite is there. So it all depends on where the angle is. Okay, I'm just showing you these because these are awesome questions. One student said, I keep getting 1 is the answer, and they told me exactly which problem they're doing. And I really appreciated it. And so I think I asked them to send me a picture of what they tried so far. 1 plus secant over 1 plus cosine. And again, changing secant to 1 over cosine is the ticket. And so you'll get 1 plus 1 over cosine. And then you could get a common denominator in the top. I'm not going to do the rest of this for the sake of time. So but this is the kinds of questions I'd like to get from you, which isn't really a question on the math, but rather a curiosity. Oh, why is cosine, sine, and such called what they're called? Most math goes back to the Greeks. They started everything. They're awesome. And it also goes back to Latin. So if you want, you can look that up, but these are Latin. They start with a Latin word and then they relate to each other. Cosine actually started with cosine, which, you know, of course, but sine is the one that started with something else. Anyway, you can look those up. And this was a good one. If it's split up, it's a negative. Could they both be negative? No, you'd have to be, remember we talked about that. The negative is on the top number or the bottom number, but not both. But these are really good specific questions, and I appreciated that. And then even just this, I don't know what I'm doing wrong. And then they show me a picture of what you're doing. Just send me the photo. It's awesome. And same with this. The pictures show me what you're talking about. The radius always be 1. Well, yeah, the unit circle it will, but we can have not a unit circle, but we can have different circles. And that's when you have to times the cosine or the sine. It's x equals radius times the cosine, and the y coordinate equals radius times the sine. The Pythagorean identity, the reason that unit circles all have a radius of 1. Just by definition, the radius is 1. And the Pythagorean identity just gives us the sine squared plus cosine squared equals 1. Okay, and we talked about this in our thing. I think that was all I got down. I felt like there's more, but okay, I am done with this. If you guys have questions, I'll take any questions. My speaker's not working. Oh my gosh. Okay. Can anybody hear me?
We can hear you.
Oh, you can. It keeps saying my speaker is not working. Thank you. Okay, so this is what I have for today. If you will be talking individually at these times that you've scheduled, I will send you individual Zoom links for that. And what else is there? Quiz, you guys, most of you guys, boys, some of you guys really like to play it right on the nose. And that's okay. It works for me. You just won't get it back as soon as because I clearly have to be here for Zoom. And please do the forums. Give me some good right triangle problems. They need to be applications, not like I gave you, but it needs to be, let's see, it needs to be, just the examples I gave you in the videos or the examples in the text. Has anybody looked at the textbook for help? Don't forget it's there. It's a good book. Okay. And otherwise I'll be talking to you another time. Okay. Okay. Thanks for being here. And hang around if you need to talk to me. Otherwise, adios, and see you next time. I'll stay here for a little bit if you want to ask me anything.
Thank you, Barb.
You're welcome. Thanks for saying thanks.
Marge, I had a question.
Yes, Jennifer.
For my right triangle forum, when I try to attach it as a PDF, it just keeps like going in circles and it won't let me do it. And then I tried it on Safari, on Chrome, and on Firefox.
Yeah.
And they all did the same thing.
Okay. I don't know why that's happening. What I did is I wrote it on without a PDF. I just did it on Word.
Okay.
In Word, and then I saved that and I loaded that up, and that worked fine with a student. If it doesn't work, Jennifer, send it to me and I'll post it for you.
Okay, thank you.
Okay. All right. Emily?
Can I change the time of my Zoom meeting?
Absolutely. Yeah. Yep.
Was Wednesday at 10 an option?
Yes, it is.
Okay. Can I do that instead of the Thursday at 10?
Okay. And you were at Thursday at 10?
Yeah.
Okay, good. Okay, yeah, that works. Wednesday at 10, I got you.
Thank you.
All right. Okay, thanks for all your contributions.
You're welcome.
Is this becoming more and more review for you?
Yeah.
Yeah.
But it's a nice refresher.
Is it? Okay, I was just gonna say, is it too much review?
No, I think it's okay because it's I remember as we're doing it, but it's there were when I would just look at the blank note pages, I knew the terms, but I couldn't remember the process.
Okay, so it's
And so it
refreshing.
Yeah.
Are you planning on taking calculus next term at
Yeah.
OCC? Okay, this will be really good then for that. Okay.
Yeah.
Good. All right. Okay, we'll talk to you Wednesday.
All right. Thank you.
All right. Bye-bye.